Hi everybody, so last time we went through the inside of this thing, the new color Duo, but I know that wasn't enough for you nerds, so I'm going to go through the inside today. We're going to tear it down and see exactly what's inside. So let's take a look at the case. So the case, all of this back part is just one big piece of bent steel. The drawer screws in to this nut plate here, which is just a threaded piece of metal which attaches to a flange on the front of the case here. So let's take a look at the circuit. So if we're coming in as a mic or line signal, we'd come in, let's say it's channel 1 here on either the mic input jack or the line input jack. And you go through some kind of receiving circuitry, some filtering just to clean up any noise on the input. And then you come through these connectors here to the drawer. But these are just basically really hefty 32-pin connectors because we figure if you're going to be plugging and unplugging this thing a lot, we don't want the connector to fail. So not only are they super hefty, but we're doubling or tripling or quadrupling the number of connectors that every signal is coming in on, up to ground, which comes through on 18 different connectors. So it's just the kind of redundancy you want when you're designing something that will be pushed in and out like this. And then we have our mic preamp section here. That's here and here for channel 2. That is based around this That Corporation 1512 chip. These chips have become kind of famous in the last 10 years or so in pro audio. That Corporation is a company in Massachusetts that's dedicated only to high-end audio ICs. But this is just a really transparent, very musical, low-noise chip. That preamp is controlled by these gain knobs here. There's phantom power and typical mic controls. Then we get into the color section. So these big white spaces here are the color sockets. Put some colors in there. I do have the power on. You're not supposed to do this, so don't do this at home. Let's put some different colors in there. Okay, so now these colors set the hue of the LEDs here, which is then reflected through these light pipe switch actuators through to the front panel. Another really nice thing these do is they diffuse the LEDs and really mix it into kind of one hue. The way these LEDs work is really cool. They're RGB, meaning they're actually 3 LEDs in one, a red, a green, and a blue. And each of the colors has resistors that set the luminosity, the relative luminosity of each color, which is then mixed and kind of blended by these diffusing light pipes. So very excited about those. Those are new with the color Duo. And then you're going to see more chips here for the trim and gain, and then one for the mix control, which is a summing amp, which sums together the wet signal and the dry signal, and then amplifies it a bit, and then the balanced output driver. All that's happening here, all with operational amplifiers, or op-amps. And for the Duo, we have chosen the NE5532, which is just a classic. You're going to find this in high-end gear, from mastering compressors all the way down to more budget gear, because it is not an expensive op-amp, but it sounds great. And most importantly for this application, it sounds great when it's working really hard. Every op-amp, almost every op-amp, is fairly transparent when it's in its linear range, meaning when it's not working very hard. But if you start to give it a little bit too much signal, you're really going to start to hear the character of the op-amp. And what I love about the NE5532 is it just has a warm, kind of familiar sound when it's working really hard, which is very easy to do with these color drive stages here. So that's why we chose the NE5532 for this kit. Let's see what else here. You're going to see these 2 big relays. These are basically to turn off power and audio when you're using the drawer. So over here in red, you'll see the active switch. What that does is it engages power to the drawer, and it mutes or unmutes the audio here. And that's just because when you're pulling out the drawer, you're breaking a connection. So there is the chance that there will be a pop, which we've all had in our speakers when we accidentally unplugged a microphone or something without muting the speakers. And we figured, let's just put that on the front panel. So as long as you turn off the active switch before you remove the drawer, and then turn it back on after you've put the drawer back in, there is no danger of anything being damaged here from hot swapping. There's no danger of any big pops in your speakers. That's the idea here. So then we basically do everything the same in channel 2, it being a dual mono or stereo unit. Another thing I want to point out on the circuit board here is that it's really designed for DIY and for tinkering and for hacking. Design for manufacturing is it's kind of its own discipline, and in our case, design for manufacturing means designed for DIY. So a couple elements that you can see are all the resistors, all the parts are in numerical order. Usually part numbers are in the order that they're found in the schematic, but then when you get to the circuit board, it's going to go R17, R55, R3, R7. We go the other way around. The parts are all numbered by their order on the circuit board so that when the guide tells you populate R1, you know to go to the top left. You don't go searching for it. So that's one element of being DIY friendly. The other is just making pads and making spacing a little bit bigger than you would if you were going to have a factory assemble this. It's just nicer to have a bigger target to hit when you're soldering and a little bit more room between parts. So things are not as squeezed together as they could be to absolutely maximize space. They're made to be, space efficient, but comfortable for soldering. And then the final element here are test points. I put in as many test points as I could possibly fit so that, God forbid, you do have an issue with this and you contact us, I can say, okay, take out a multimeter and probe between color 2 and ground. What resistance do you have there, et cetera, et cetera. And you can do your own testing or you can do your own kind of learning about electronics that way by looking at our publicly available schematic and probing through and seeing what kind of voltages you get in different places, that kind of thing. So just something that, maybe most people wouldn't notice about the circuit board, but boy, is there a lot of thought and effort that goes into making it DIY friendly. So that is the Color Duo in a nutshell. Overall, the philosophy here is, to give as much power and control over the preamp, over the colors, while staying out of the way sonically. And so that's why we chose the 1512 for the preamp. That's why we're using ICs for the balanced inputs and outputs, and rather than Class A discrete stages and transformers and that kind of thing, because the attitude here is from the colors. And our job with the Duo is to make the colors happy, give them the signal they want, the power they want, while staying out of the way sonically. So that's the overall design philosophy. I hope you found this to be illuminating and enjoyable. It is November 2020, and we are still taking pre-orders for the Color Duo for the first batch that is set to ship in December. So next month, coming up fast. So get that pre-order in if you're interested. We're closing at the end of November, and thank you so much for watching.